This is a simplified diagram of the A330-200 fuel system. The system includes a fuel tank located in the trimmable horizontal stabilizer, which is controlled by a fully automatic stabilizer trim tank transfer system. The system controls the center of gravity, or CG, of the aircraft by transferring fuel to or from this trim tank to maintain a CG within 0.5% of a target value. When fuel is transferred aft to the trim tank, the CG moves aft. Conversely, when fuel is moved forward out of the trim tank, the CG moves forward. It is through the movement of fuel back and forth in this manner that the trim tank transfer system controls the aircraft's CG. The purpose of the automatic transfer system is to increase fuel efficiency by managing the airplane CG, thereby reducing airplane drag. The shaded area illustrates the range of CGs that is controlled by the trim tank transfer system. In this view, the range of CG control is shown at the bottom of the diagram. The red line illustrates how the CG moves with each fuel transfer during a typical flight shown at the top. Early in the flight, the system transfers fuel into the trim tank until the trim tank is full or the CG reaches the target. Normally, only one aft transfer of fuel is required per flight. As fuel is consumed from the main fuel tanks, the CG moves aft. When the CG reaches its aft target value, which is approximately 2% forward of the aft CG limit, the system transfers fuel out of the trim tank forward to the inner main tanks until the CG is 0.5% forward of the target value. Then the cycle repeats itself with a series of fuel burn and forward fuel transfers to maintain aircraft CG within this 0.5% CG region. A final forward fuel transfer occurs when the airplane is within 35 minutes of the destination, when the quantity in either of the two inner main fuel tanks decreases below 4,000 kilograms, or when the aircraft descends below 24,500 feet. This diagram illustrates how the trim tank transfer system moves fuel to and from the stabilizer trim tank during normal operation. For clarity, this simplified fuel system diagram does not include the engine fuel feed plumbing or the center fuel tank. Early in the flight, the left and right aft transfer valves, the trim pipe isolation valve, and the trim tank inlet valve open to allow fuel from the engine fuel feed plumbing to flow aft to fill the stabilizer trim tank. These valves close when the transfer is completed. Once in cruise, the CG moves aft as fuel is consumed until it reaches the target value. The system then opens the left and right inner tank inlet valves, the trim pipe isolation valve, and the trim tank isolation valve to allow fuel to flow from the trim tank equally to both inner fuel tanks. These valves close when the CG moves 0.5% forward of the target value. Then the cycle repeats until the final fuel transfer as the airplane nears its destination. During the accident flight, the trim tank transfer system functioned normally. After the fuel leak began in the right engine, the automatic forward transfer of fuel occurred significantly before it normally would have because of the fuel loss in the right inner main fuel tank caused by the leak. The accident investigators recorded two forward fuel transfers. The first smaller transfer of 300 kilograms lasted for 2 minutes. The second longer 19-minute fuel transfer transferred the remaining 3,200 kilograms of fuel out of the stabilizer trim tank. In addition, the system transferred more fuel to the right main tank, which was lower due to the fuel loss, until it equaled the quantity in the left tank. This automatic fuel balancing function of the trim tank transfer system delayed the display of a fuel imbalance ECAM message, which would have alerted the flight crew to the abnormal fuel state. The accident investigators determined that this automatic trim tank transfer and fuel balancing delayed generation of an ECAM advisory fuel imbalance message about 25 minutes and contributed to an unnoticed loss of 3,500 kilograms of fuel.